So today we're going to cover a quick walkthrough of OpenAlex, what it does and what it doesn't do well, and how VantagePoint can help. So OpenAlex, all the world's research, connected and open, 474 million scholarly works, wonderful, wonderful potential resource. So with any source, always check the fine print. So there's marketing and then there's reality. So before using any data set for analysis, we need to learn a little bit about how it's produced. It does take a little digging, but you can go into the OpenAlex help where they actually start giving you some details about OpenAlex and where it came from. It is essentially a follow-on to Microsoft Academic Graph, which shut down around 2021. And they basically took the Microsoft Academic Graph back file and brought it on when Microsoft stopped doing it. And they set it up with OpenAlex, basically using the same data set. Now, OpenAlex, what is actually in it? Primarily, you have web crawling results, that technique that they developed in the Microsoft Academic Graph, but you also have things like archive and PubMed. And then there's a heavy reliance with Crossref, particularly using DOIs to assess citations between records. And they also have a lot of other potential sources where they get a little vague in terms of what they are, but it is an interesting approach to collect what, in the end of the day, instead of the 478 million records you're talking about, there's actually around 240. Now, as a sanity check, I always like to go out there and look at whenever these type of, whether it be OpenAlex or Lens or Google Scholar, the question of how much science is there really out there. Just kind of as a benchmark, PubMed, which is about 40 million records going back to the 1950s, which includes well beyond journal articles, also includes books, letters, reports, and things like that. Web of Science, which goes back to about 1900, has about 100 million records. Scopus is a similar size, going back to 1970. And then InSpec, to put it in going into a specific technical database, is about 25 million records. So starting off with 478 or even down to the 240 million means that there's potentially a lot more, or potentially something else in these sets. So let's look at OpenAlex and see if we can figure out a little bit of what's going on. So I've got OpenAlex here, and right now it starts off with your 480 million scholarly works, but in reality there's at this point 289 million works. And so let's you've got this nice interface where you've got records, you've got these little widgets over here which you can change which widgets are being displayed, and they have a lot of interesting potential things that they're extracting out of the data. Now, some of this stuff is fractional coverage, some of it's extensive. You can see things like what's essentially in PubMed, what's covered in ORCID. So there's lots of clever stuff that they're doing here, which is kind of new and novel for the information space for science and technology. But let's play a little ground truth here. So I'm going to start with looking at authors, and I'm going to look at myself. Now, kudos to them for deduping all the variations of my name over the years. So I give them credit for that. I have several different variations of my name out there in publications, but we immediately start seeing some interesting problems. Right now, I'm supposedly in Poland. I have never done anything with Utah State University. Some of these other ones are correct. And 6 more we can check, but anyway, and yes, I have an ORCID score, and then it's saying I've got 60 works, which is roughly correct. It depends on which source you use. Web of Science, I'm lower. Google Scholar, I'm higher. So there is a lot of variability between the sources. So let's look at my 60 records that are in OpenAlex. Now, couple of things right away. I have no idea what this is. The Interaction Institute for Social Change. I know what the acronym stands for. It is not that. So how these items are created starts becoming an interesting question. A lot of the institutional stuff I know is an issue with ROR. So they're going out to ROR and using ROR to dedupe and identify basically one single institution, clarify what multiple versions of an institution's name into one single institution. ROR does really good work, and I know it's a really hard problem, but there are a lot of things that ROR is not really good at, and there's some issues that ROR has addressed, such as they lump everything from the Chinese Academy of Sciences into one Chinese Academy of Sciences. They changed that recently. There's a question as to whether or not this file back indexes data. It also becomes an interesting, I mean, the topics are actually pretty good. The year profile is actually correct. This is the key bit up here, which is the open access. This is telling you that less than 20% of my works are available freely on the internet. The rest of the stuff is behind paywalls, and that's where some of the interesting challenge occurs in this data. Because a lot of the text analysis that they're doing is either off of web scraping or the stuff that's in public domain in open access. But the stuff behind paywalls, that gets to be an interesting problem. So let's take a look through these, and actually most of them look relatively correct. But what I can do is I can then export that data out using the download button here, and I'm going to do a little bit of basically the baking approach and just show you. Oh, I exited it, brought it out. I imported it into VantagePoint using the import filter that we have inside of VantagePoint for OpenAlex. And lo and behold, here you have the resulting 60 records. So we see right away that a lot of fields, but it's mostly standard bibliometric fields. You'll note that none of the widget data comes across in the export. And the widgets are actually exportable, but they're only exportable as CSV files or API, but they're not tied to the data. So we don't have all that rich keywording and other things, information in the actual export, which is a bit of a shame. We could potentially stitch it back together using an API, but that gets to be a bit problematic, particularly depending on how the API is responding. But let's take a look at the authors first. And so I'll go into the authors, and yes, there's me, there's Alan Porter. So that's and Dr. Ressner and Jan Udy. This all makes sense. It gets interesting down the bottom here because I start recognizing names of people I've never spoken with. And I did a little digging in that, and it's due to books. And so when Dr. Porter and I work on a book chapter, every single author involved in that book becomes, in essence, a collaborator of me, which makes bibliometric analysis for team analysis kind of interesting. Let's go into the titles. So we go into the titles themselves. Let me make that a little bigger for you. And we start saying, I have never written an article called Allo Collection. So this thing is starting to generate data from, well, on its own, essentially. And if we go on and we look at the actual record called Allo Collection, we find some interesting characteristics. There is no DOI. There's no way to actually look at this thing. There's very little information in this record. So it is hallucinating a little bit, some of the records. And all in all, it was not too bad. It's just I'm nitpicking here in terms of, out of 60 records, 1 or 2 are essentially hallucinations, which is not too bad, but is something you should keep in mind when you're looking at it in terms of bibliometric analysis. So you magnify that. 60 is a fairly small collection. If you imagine you're trying to analyze an entire organization, that you might have a fair chunk of the data actually not being, well, real. There's also some of the index structure is coming across. So let's take a look at the publication type. this one fascinated me because I thought for a minute that they were actually going out and mining patent data in the ROR, patent data in the OpenAlex data file, but it turns out classifying one of my publication types as patents is simply a function of the fact that it is an journal article about patent mapping. So these are machines making these decisions. There's probably very little human oversight, so it can make mistakes essentially. So this is a preprint of a patent, which is not true. It's a journal article, and it's pulling it from a preprint. And in reality, if you go to the DOI, we can see the archive version, but the article is actually, I believe, an Elsevier publication. All right, so a little bit of buyer beware. Now, these things are not complete showstoppers. We can fix some of these things using the tools in VantagePoint. So, for instance, on well, go into the titles themselves and just eliminate, creating a subdata set with no allo collection for one thing. The author field, we can go through and remove the authors that are essentially from book chapters, and that will clean up and allow us to have a more effective set for doing co-author analysis. And the publication source is also, let me see, find the publisher, publication name. That's what I'm looking for. That's essentially the journal. This is also something where we can go through and well, let me go into the AGAU or the AGU fall meeting abstracts, where apparently I wrote an article called "Brain Gauges Everywhere: The Limits to Public Participation." That is clearly nothing I've ever written. I don't know who these people are. It is from a meeting abstract. Now, there might be another Nils C. Newman out there, but I've checked over the years, and one of the fun things about me and the internet, for the longest time, there's never been another Nils C. Newman. But I would double check that to see if that actually, and because there's no DOI, I can't actually go in and look at the record to see if this is a mistake or if there indeed is another Nils who is writing about ring gauges. But it's easy in VantagePoint to find these things and remove them if they don't look like they make any sense. The other fun stuff with a source like OpenAlex is it is bringing in, it has a fairly broad spread. So it is actually bringing in the translated works from basically Chinese Academy of Sciences is published some of our, well, taken some of our works and converted them into Chinese. And so it is actually finding those, which is pretty clever. So we could do some selective cleaning on this, and we'd actually have a pretty reasonable set for looking at journals, looking at, or sources looking at people. Definitely the date ranges work rather well. So that is let's just go into the year published field. Actually, that makes sense, and so the histogram of my publishing makes sense, and the citation patterns are also not identical to other sources, but there's always a lot of debate as to where a citation is being pulled from and how. OpenAlex's citation collection is supposedly around 2 billion citations. Web of Science is about 1 billion. Google Scholar is around the similar couple billion citations. So it's probably not bad for that at all. All right. There are other little things I go in for the sake of time. I won't cover them, but it is important to note in here that, yeah, all the fun stuff, the meat that we use for doing a lot of our term analysis is missing. Number one, because it has its restrictions. There are abstracts, but they won't let you see them because that's how Microsoft Academic Graph got in trouble for violating copyright. So we don't have an abstract to play with at all. We have a title we can work with. We don't have any index terms. We don't have any descriptors. All that stuff is not there. So the kind of term-based analysis that VantagePoint is known for is basically not something you can do when you're working with OpenAlex data. So let's go back to the presentation. And one quick thing I wanted to talk about was the where they are actually pulling this information from. And so on the right, pick this one right here. So if you can imagine, if we go out on the web and we see this is a publicly displayed open website, the article itself is behind this one. Actually, we paid to have available, but the abstract is essentially what they're web scraping. And so they can pull this information off, and they're trying to make all these connections based on what's here. And this one's got a nice meaty abstract, but some of them are a little more sparse. But this is in Plum, so this is Elsevier, an Elsevier article. So this is basically what they're going out and finding on the web, and that's the basis of Microsoft Academic Graph. Is they said go out and find these things that look like this on the internet and scrape all the information off of it as best you can, and the key bit being as best you can. So it does have some interesting results on some of the stuff. So definitely noisier than your standard bibliometric data sets. So summarizing pitfalls. Abstracts only. Abstracts not available, or if it is available, on the website, it's open access. It's not available in the downloads. The widgets are fantastically neat, but I worry a little bit about the reliability, particularly since they can only be exported separately in CSV format or through the API. So ground truthing those is a challenge. You can try one record at a time and then check the widgets versus reality to see if you trust what's in the widgets. Or if you want to spend the time and effort, you can go through their API interface and try to upload all the widget content to the right record using a DOI. Of course, if the record doesn't have a DOI, then that might be a challenge. The institutions are claimed by Roar. I got a lot of respect for Roar. I know how much of a challenge what they're doing is. It is getting better. So the Chinese Academy of Sciences, well, the one that was relatively recent is they actually started taking everything from the University of California system. It used to just be classified as University of California, which is a lot of universities, and actually separating those out. There's not any indication that I'm finding that they're back indexing the data in OpenAlex. So if you looked at something 5 years ago, it might have University of California. Now, if you look at the same rated record from 5 years ago, I don't think that's changed. But if you look at a new record, it will actually be UCLA. It's interesting to how they I couldn't get a sense going through this thing how they handle longitudinal changes. The production system is clearly making stuff up. I don't know how bad a problem that is, but it does happen. And the coverage is also tricky. It's really hard to parse out from their documentation which data sources were brought online when and to what extent they've been updated or changed over time. It is a cobbling together of a lot of different sources, and particularly since they've taken that mag back file and that's their starting point from a few years ago, and their process going forward is not clear to how much of MAG's approach they were actually allowed to continue. How much did Microsoft actually give them, other than the back file? But the process of actually producing the stuff is a little gray there. And then the longitudinal consistency is really unclear. I would really be hesitant to use this for longitudinal analysis. So VantagePoint can help. Vantage easier to spot the issues and errors. List cleanup to help sort out some of the data. Manual correction is also an option, and sub-data sets to remove noise. And so there are ways to actually deal with some of the issues to make it an effective tool for analysis. Can't really help on the missing abstracts because the text capability of VantagePoint is just simply unavailable. The data aren't there. Same thing with the index terms. You can do some backfilling with DOI, but at that point, it's probably easier just to go back to the original data source. So for instance, all the stuff from PubMed, you get a much richer set if you just pull it out of PubMed. So to sum it up, it's an intriguing free data source. if you're using OpenAlex to identify specific starting points, you go out to a paywall or other system, it would work great. In other words, you start your query in OpenAlex just to get a sense, and then you go out to more detailed data sources to your actual analysis. But if you're doing pure analytics, looking for trends and looking for changes in topics and institutions and article types over time, you might find that the free actually creates a lot more labor for you. I don't want to sound like I'm picking on that, but I do want to point out that this is potentially a kind of a profound thing. There was a recent press release from CNRS stating that they're dropping access to Web of Science and to Scopus, and they are suggesting that their researchers use OpenAlex. And I think that's for anyone doing kind of bibliometric analysis, I think that's a not particularly great decision. So that being said, I hope you've enjoyed it, and thank you for your time.